Welcome class 8. Today we will learn about pressure exerted by gases. So the earth has a thick blanket of air around it, which we call it as an atmosphere. And this atmosphere, or we can say the air, has weight. Therefore it exerts pressure on the surface of earth. So it exerts pressure. So this pressure is known as atmospheric pressure. This pressure is exerted in all directions, not only downwards. So all the gases exert pressure equally in all directions. For example, in a balloon, air inside exerts pressure in all directions. So here we can see the air inside the balloon exerts pressure in all the directions. That's why we see a balloon in this shape. And similarly, the air outside the balloon also exerts pressure in all the directions. So here we see that air inside as well as outside exerts pressure in all the directions. Atmospheric pressure depends on mass of air above us. Mass is related to density, thus pressure depends on density of gas. So we know that pressure now, since it depends on mass, more the mass of air above us, more will be the atmospheric pressure. And if the mass of air above us is less, then the atmospheric pressure will be less. So we can say that mass again is related to density, because more the mass, more is the density, and less the mass, less is the density. So thus pressure also depends on density of gas. So as mass is more, then density is more, and if mass is more, then the pressure is more. So we can say that more the density of gas, more will be the pressure, and less the density of gas, less will be the pressure. So here we can understand that if the atmosphere on top of us, okay, if you are on top of a mountain, and if the column of air above us on this place is less, then we can say, since the mass is less, so we can say the pressure out here is also less. And down here at sea level, we can see the whole column of air above us is more. So more mass, that means more pressure. So this means that atmospheric pressure at sea level will be the highest. And as the altitude of a place increases, the air column above decreases, hence the decrease in the air pressure will result. Atmospheric pressure on mountains is less. Thus, the mountaineers carry their supply of oxygen in cylinders. So here again, we can see at sea level we have this much column of air. So the air pressure over here is maximum because the mass of air above the sea level is more. So here at sea level, the atmospheric pressure will be more. As we increase our height or altitude, the column of air above us will be less. So, as the altitude of a place increases, the air column above will decrease, and thus decreases the air pressure. So, on top of the highest peak of the mountain, the air pressure will be very less because the mass of air will be less. So, in that case, the mountaineers, they carry their supply of oxygen, because at the tip of the mountain, you know, the oxygen level will be very less, so they need to carry their own oxygen cylinders. Now let's say that there is a beaker, okay, which has a tightly fitted piston on top of it, and there is a fixed amount of gas uh, inside in that beaker, okay, and this piston can be moved. So if you apply some force and if you apply some pressure and if you move the piston forward, then this amount of gas whichever is there, the amount of gas remains the same, but its volume, the volume over here is this much, its volume will get decreased like this. So when the piston moves forward, the volume of air inside is decreased. So we can say when the pressure is increased, as you increase the pressure out here, you pressurize the piston to move forward, the volume gets decreased. So when the pressure is increased, the volume decreases. And just the opposite, if the pressure is decreased, if you remove the pressure, then again this piston will move upwards. If you decrease the pressure, then the volume of air, or sorry, the volume of gas will increase. So when the pressure is decreased, the volume increases. So in the similar way, we can say that if the volume is increased, then its pressure decreases, or if the volume is decreased, then its pressure increases. So when the volume is increased in our body, while breathing, when the volume is increased, all right, the pressure decreases. So since the pressure inside the lungs decreases, the pressure outside will be more, and thus the air will move from outside towards our lungs. Okay, so when the volume increases, the pressure decreases. So this is how it works on the animals when we are breathing. So here we see a picture where a child is using a straw. So usually when we drink juice using straw, we suck in air from the straw and the pressure inside becomes less than the atmospheric pressure. So when we are sucking the the straw, the atmospheric pressure at this point gets reduced. Okay, so here if the pressure is reduced, so the atmospheric pressure over here, it is applying a constant pressure. So this pressure will make the liquid move from the glass through the straw where the atmospheric pressure is less. So as a result, the atmospheric pressure pushes the liquid downwards. So this atmospheric pressure is pushing the liquid downwards. Now it needs to go somewhere, as the atmospheric pressure is pushing the liquids downwards. So it must be, it must escape from this straw. So the liquid downwards, forcing it up through the straw. So then it moves up through the straw. Similarly, in a similar way, a syringe also draws the vaccine using the atmospheric pressure or air pressure. And also the atmospheric pressure outside is balanced by the blood pressure inside our body. Since the air column above us, above our head, it has some mass, that means it has the atmospheric pressure, and that pressure should crush our body, isn't it? But here, since the body is well balanced by the internal pressure that is created by the blood, so this pressure from inside and the pressure from the atmospheric pressure outside is always well balanced. So thus we don't feel any difference. So this is the atmospheric pressure, which is balanced by the blood pressure inside our body.